Hello. Today I want to show an update to the key value pair that we worked on in the last video. If you haven't seen the last video, I'll include a link in the description and at the top of the screen. If you remember from that video, I talked about the key value pair and how I have some clumsy things like storing multiple copies of data or storing data in multiple formats. So I'm trying to fix that today by having a more generic key value pair. I've taken this key value pair class that we built last time, I've renamed it to KV pair 1, and then I've made an exact copy and renamed to KV pair 2. So these two classes are identical apart from the name. And then I've created this script to test that they do the same things. I'm including both key value pair files. I'm creating an object of each key value pair type, passing in exactly the same values. And then I'm changing that value to different types and values, and after each of those I'm calling this compare function, or I'm passing in the type that I'm using for that key value pair at the time, and in the compare function all I'm doing is extracting the type name, the value, and the toString value from each of those key value pairs, and then I'm just running through some comparisons to make sure they're the same and printing matched or not matched if the two return the same value. So I will just compile that quickly and show you what it does when we run it. So I've cleared the experts panel in MetaTrader here, and if I just go over here now and run this, and we can see everything is matched. I'm going to modify the KV pair 2 class to be more generic. Now there was nothing wrong with the earlier class, it worked for its purpose, but this is a good exercise in showing how to use some of the techniques available, and this will also allow you to create a class that is easier to extend because there are less modifications to make as you add more data types. Now what I want to do, instead of having these independent variables of type string, integer, double and so on, I want to have a single value, but that variable needs to have a type, and I don't have a type here to assign. So it might seem like an easy idea to simply take this templating and apply it to that value. But this simply won't compile. I'll just try that so that we can see the error. And there's the error, template cannot be used for data declaration. You can't do it. What I can do though is apply a template to the entire class. So I can take that statement, and by placing the type name template outside the class, I can use this T anywhere inside the class to represent this generic type name. I'm also going to make it a little bit more descriptive while I go through. So a few changes I need to make here for this. Because I've applied a template to the class, I remove that template from the constructor statement. I remove the template again from this get function and from the set function. I do need to leave the template on these function definitions. These are outside the class description here, where I've terminated the class, so I need to apply the template to each of these. And here previously in this toString function I didn't need to use the template, but now because it's part of a templated class I need to add this template statement to that function even though I'm not using the t-value type in this function at all. So now that compiles, but this still has a problem. And if we come back to the test script and try to compile that, we get this template mismatch error. And that's because now that I've templated the class, anytime I want to use the class, I have to indicate a type name here, which I can do easily enough. But then even now, if I compile, forgot to change one. Okay, go back and try that again. Now we can see I need to apply that typing everywhere that I've used CKV pair 2. And that means that once I've defined my object CKV pair 2 as a particular type, I can't change that. And if we look further up here, previously I'm simply able to assign new values and have the class contain different values as needed. Now that I've got templating around the class, I will have to create a separate class for each data type, which defeats the intent of having a totally generic key value pair. So that's not the answer that we want. So going back to the KV pair 2 class, what I'm going to do instead is create another class type which will just hold this value. So let me create quickly So now I can create a class of CKV pair value, which just holds this one value. I'll need to add a constructor to that. And all the constructor will do is a simple value assignment. Now, because I'm using templating here, this value is always the same value as used in the template, which means it will be the same type as the value passed into the constructor. And then in the CKV pair 2, I can define CKV pair value, and that's a pointer, so I need the asterisk. But now I'm going to have the same problem inside this class that I had inside the script. Everywhere that I declare this, it has to be declared with a type. And the solution to that is then to create a base class for this, which I will do now. Now, having done that, I can declare my value of type CKV pair value base, and now I just need to put the template statements back into this class anywhere that I'm passing a value in. So let me do that. And now I don't need this because the templating is not used in the toString method. Let me just see if that compiles. That one compiled. I need to remove this now. Don't need that templating. So I've got no errors. These warnings are from implicit conversions because I'm using a lot of generic statements. So now it compiles, but I need to do some more things to make it useful. First, we no longer need to store this type name. We were storing it previously so we could return the type name, but now we can get the type name directly back from the value. To do that, I'm going to create a virtual function inside the value base, because if I'm going to call a function from within this class, I need to call types of CKV pair value base. So first create the virtual function in here. And you'll see here that I've created a virtual function of type string. Instead of the usual syntax though, I've added this equals 0. That will define this type name as a pure virtual function, which means that any class that inherits from CKV pair value base must implement this. If you remember from other virtual functions, they could only exist in the base class if wanted, and there have been times where we've created subclasses that simply didn't bother to implement these because the functionality in the base class was enough. In this case, I'm forcing that to be included in the subclass. This also makes the class CKV pair value base a pure virtual class, which means that I can't create an instance of that anywhere. I must create instances of the child class. So now, having declared that virtual function, let me create the implementation here in CKV pair value. And that's pretty simple. All I need to do is get the type name of the value that's stored, and I can return that. So this is becoming more generic already. Then down here, I'm removing this type name, and in the get type function, I'm now going to return value.typename. The next thing to implement is the get function. Look at what we had previously. I was comparing the type name, which we no longer have, and returning different values depending on the type stored here. We no longer have that. What I'm going to do then is create a get function inside the pair value class. So that obviously returns a value of type T value. That's a very simple function there. Then in this get function, and I can put this on a single line now because it's become much simpler. But I can't simply return value.get. I need to assign a type to that value, and it needs to match this T value. Now value is an object, so I can cast this. Remember that value is stored in this class as a CKV pair value base. The value base doesn't have the get function, but I can cast this to the child class. And casting is just a matter of putting the type inside parentheses. CKV pair value, and remember CKV pair value is a templated class, so I need to include T value, which I have here because it's passed in when I use the get function. So now I have that, and just to make sure that the templating applies to the object and then I execute get against that object, I'll put all of this in parentheses. So all of that becomes the object that I'm applying this get function to. So that's much simpler than the previous implementation of get. And now that I've put all of that onto a single line inside the class declaration, I need to remove this function completely. One error, that's because I still have type name here. I'll just get rid of these. So no errors there. So in my KV pair 2 class now, my constructor hasn't changed. The destructor needs to change because now my value is an object. So I'm just going to put in a statement here: if it's been instantiated, then I will delete that object. That takes care of the destructor and getting rid of the value object if it's been instantiated. We've set up a new get function. The set function needs to change as well. So let's look down at the implementation of that. Previously I was capturing type name, which we no longer have, and using a set value function. But because my value is now an object, if I'm going to set a new value, all I'm going to do is delete the existing object and then create a new instance. So let's just do that. Alright, now in this function we're getting the t-value type passed in because it's part of the function signature. That means that I'm able to actually use it here in the constructor for CKV pair value. So I'm able to actually create the child class or an instance of the child class here. Although my value is defined as the base class variables can store instances of the child class. So I'm able to create one directly here. And so I'm just using the constructor for the pair value class, passing in the value, and that's all I need for the set statement. Now the toString method. See what we had before. Previously, and I've just deleted these lines, we had separate statements that return different values for the toString depending on the type of the variable. I'm going to create this as a function inside the pair value class, and I'm going to make it a virtual function. So I'll do this again. Now the function here. And previously, when we called these toString that had no arguments in the function, I was just calling another toString method and relying on overloading to call the appropriate toString depending on the type of variable. And I'm going to do the same thing here. So just calling this generic toString, we'll then call toString passing the value, and I need to create these toString methods. And they are the same methods that we had here previously. So I'm just going to copy all of that and delete the lines I no longer need. And I'm going to put those in the base class. I could put them in the child class, but just in case I want to inherit from this for another pair value type, if I put them in the base class, then they're generally useful. So all I need now are these two string methods. And so there's still an element of clumsiness here, that if you extend this, you'll need to create more of these two strings. And at the moment, these are only working for the base data types. So strings, integer, double, date, time, you can add booleans, anything like. But if you wanted to use this for an object, you'll have some more issues. And I have a follow-up video coming where I show you how we can store objects in here as well, and also use the toString method on those. But for now, I've created the toString method. I can delete all of these statements where I was storing independent values depending on the data type. And for my toString now, all I'm going to be doing is and then I will remove the implementation I had for toString here. So now my class compiles. Let's just quickly look at it again. I've created a base class, has two virtual functions, type name and toString, and at the moment 4 functions for converting the value to a string. The pair value class inherits from pair value base, and it's a templated class, so I'm templating the type name of tValue. Then the constructor takes this tValue type and just assigns it to the internal variable value here. And then I have implemented the 2 virtual functions, type name and toString, and I've created a get function here that just returns the value. In the CKV pair2 class then, I still have the string of the key. I've implemented a value object of type value base. Constructor hasn't changed because I'm still calling this set method, but the set method has changed to instantiate an object of type CKV pair value base. In the destructor, I have added removal of the value. The get function simply calls that get function from the CKV pair value class, and I'm having to apply the templating here in casting the value object to that type. But if we look at the way we call get, we are passing in the type name tValue. Let me just quickly show you here. When we're using get, we are actually calling it with a specific type. So you're expected to know the type before you call that get. And then in the set function, which we have here, I'm deleting value if it's been already instantiated, and then I'm simply creating a new one using the child class, passing in the type and the value. Then get key is just returning the key, and get type is calling the virtual function for type name from the value. Just a quick check, that compiles. I forgot. Value is an object and it's a pointer. So in this casting, I actually have to include the asterisk. So I'm casting to a pointer to that class. Go back to here again, and that compiles. I still have the warnings because of the implicit conversions, but that is compiled. So now if I clear what I had earlier, and then I can run this again, and here you can see everything has matched. So that has converted the KV pair 1 to a more generic class. If we look back at KV pair 1, if I wanted to add another value type, I would have to duplicate these 3 lines, duplicate one of these lines, and one of these lines. So while this worked, it was a little bit more difficult to expand. If I wanted to add another type here of, let's say, Boolean, the only thing I would need to do is duplicate one of these lines to return the appropriate string value. Everything else will simply work. As I said, I have a follow-up to show you how I can then add object storage to this. I hope you found this useful. If you have, then please leave a like. Those likes help us to make more of these videos and to know what you want to see. And if you do want to see more videos, including the follow-up where I show you how to store an object here, then remember to click the subscribe button and click the bell to be notified when a new video comes out. Until then, thank you for watching. Goodbye.